Hello everyone. In today's class, we are going to learn geometrical interpretation of indefinite integral. So, let us take one example. With the help of example, this can be understood easily. So, let fx be any function minus 2x. Now integral of this minus 2x dx, we represent this by y. Obviously its integral will be minus x square plus c. So we get here y equals to minus x square plus c, where c is the constant of integration. For different value of c, we get different value of y. So put here some value of c, put c equal to minus 2, minus 1, 0, 1, 2, and so on. So different functions like y equal to minus x square minus 2, y equal to minus x square minus 1, y equals to minus x square plus 0. So y equals to then 1 minus x square plus 1, and y equals to minus x square plus 2. So here I have written 5 different functions by taking different value of c. Now we try to plot the graph of the following functions. Zero. Now consider first function. Its maximum value will be minus 2. So mark here 1, 2, 3, 4, 1, 2, 3, 4, minus 1, minus 2, minus 3, and minus 4, minus 1, minus 2, minus 3, and minus 4. This is the x-axis and this one y-axis. So try to plot the graph of first function. Obviously it is a parabola, and maximum value of y will be minus 2 when x becomes 0. So this is the maximum value of y, and parabola will open downward. So this type of graph will come for the function y equals to minus x square plus minus x square minus 2. Similarly, other function x square minus x square minus 1. So maximum value will be minus 1, and it will pass from this point like this. So this is the graph of y equals to minus x square minus 1, and the next one y equals to minus x square. So it will pass through origin. Its maximum value will be 0. So y equals to minus x square. Now minus x square plus 1, this, and this is y equals to minus x square plus 2, y equals to minus x square plus 1. So here we got 5 different curves. All are symmetrical about this axis, vertical axis, y axis. So curves are symmetrical about vertical axis. Now you draw a line perpendicular to x-axis. X-axis, that means variable of integration. Variable of integration is here x. So draw any line parallel to y-axis and perpendicular to x-axis. Let the equation of this line is x equals to a. It cuts the graph at point P1, P2, P3, P4 and P5. If you draw tangent to the curve at the point of intersection of the curve and this vertical line perpendicular to x-axis, you will get so we have drawn here tangents to each graph at the point of intersection. So all tangents are parallel to each other. Why it becomes parallel? You see here. So fx equals to here, fx is minus 2x. Now you find its, no, fx, that means y is here minus x square plus c. So find its derivative, dy by dx equals to minus 2x. Now derivative at point x equals to a, dy by dx at x equals to a will be minus 2a. So x coordinate of each point of intersection is same, that is a. So derivative of y with respect to x at x equals to a is same for all the curves. It means slope of tangents are equal. So we can write slope of tangents to the curves are equal, and that is equal to minus 2a. So we can conclude here, geometrically indefinite integral represents a family of curves having parallel tangents at the point of intersection of the curve and line perpendicular to x-axis, that is variable of integration x. So this is the geometrical meaning of indefinite integral. So let us write this geometrical meaning in words. Geometrically indefinite integral represents a family of curves having parallel tangents at the point of intersection intersection of the curve and a line perpendicular to x-axis. X-axis, that is variable of integration. Variable of integration. Here variable of integration is x. That's why we have taken line perpendicular to x-axis. So noted down this, and you have to learn this also. Some question may be asked from this theory. So only theory we have to learn. Now next is methods of integration. Methods of integration. Methods of integration, there are three methods to find integral. Methods is only for change the given function into its standard form, so that by applying the standard formula or our given formula we can get the integral. So first method is integration by substitution. Integration by substitution. Second one is integration by parts. Integration by parts. Third and last method is integration by partial fraction. Partial fraction. Partial fraction we apply in a rational function whose numerator and denominator are polynomial, and integration by parts we apply for finding the integral of product of any two function, and substitution we use to find the integral of function which cannot be evaluated directly. So we have to reduce the given function into standard form. So let us see one by one. First of all, integration by substitution. So what is integration of substitution? This is a method. This is a method to reduce a function to reduce a function into standard form by using proper substitution. In this method, generally we apply this method in this type of function. Let this is a function of f is a function of phi, and phi is a function of x, and derivative of phi is given in product form. So in this type of function we apply substitution. Here if you observe, f is a function of phi and phi is a function of x, and derivative of phi x is given. Here we substitute phi x equal to t. and differentiating this with respect to t, both sides, and we get here phi dash x and dx by dt. If dt will go right side, then it will become dx and dt. So after substitution, we got this type of integral f phi x t, so t, and f dash x dx equal to dt. So now function became standard form. So f is a function of t, and we have to integrate this with respect to t. So here we can apply the all standard formula, and we will find the integral. Okay. Now next thing, one by one, we will learn how to apply this methods of substitution. Next, integration of the form this integral of the form ax plus b dx. If function is given, f is a function of ax plus b, not x. So x has been replaced here by ax plus b. So let us prove one theory. If integral of phi fx with respect to x is phi x, then integral of f ax plus b with respect to x is phi ax plus b divided by a plus c. First we prove this theorem. So question is this: proof f ax plus b dx. Put ax plus b equal to t. Now differentiating both sides with respect to a, at t, a dx equal to dt. So this will become I equal to f t and dx equal to dx equal to dt by a. So dx equal to dt by a. 1 by a ft dt, and integral of fx is phi x, that is given. So here same function, only variable has changed. So accordingly we can write here 1 by a phi t plus c. Once again replace back value of t. So 1 by a phi t is ax plus b plus c. So we got here very important formula. If the integral of fx is phi x, instead of x, if ax plus b comes, then integral will be same, phi ax plus b divided by a, means coefficient of x is a. So we divide the whole integral by coefficient of x. In derivative we multiply the coefficient of x. So let us apply this formula in some questions, like ax plus b to the power n dx. What will be the integral of this? So integral of x to the power n, we know x to the power n plus 1 divided by n plus 1. So in the same formula we apply here also. So ax plus b whole to the power n plus 1 divided by n plus 1 and divided by coefficient of x, that is a. So a is here, a, this plus c. So nothing will change, the formula will be same. Now take one example, 2x minus 3 to the power 4. What will be the integral of this? Here again x has been replaced by ax plus b. A is 2, so 1 by 2 coefficient of x and 2x minus 3 to the power 4 plus 1, 5 divided by 5 plus c. I think you got it. So if x is replaced by ax plus b, we don't use substitution.